Let's talk about triangles. Triangles are very important, and you must have learned of them in middle school, maybe even in, of course, in your geometry course. They talk a lot about triangles. There's a few things I want to mention about triangles. First of all, they can be classified based on their side lengths, right? So if you have a triangle, right, a shape with three sides, you have a triangle where both two legs or two sides of the triangle are equal. We call that an isosceles triangle, right? An isosceles triangle has two sides that are equal. Then you have a situation where they're all equal, right? This is not drawn to scale, and that is called an equilateral triangle. Then you have a situation where none of the sides are equal, and it's called a scalene triangle, right? So you have isosceles, equilateral, and scalene. Basically, that is a breakdown. One of the topics you learn in geometry, in a typical geometry class, is similar triangles, right? If two triangles have the same set of angles between them, but they're not the same size, the lengths are not the same, right? The side lengths are different. You can use the relationship between A, B, and C, D, E, and F, right? If there's a relationship here, you have like A over D is equal to B over E, for example, right? I'm just giving you an example, which is equal to C over F, right? That's where we talk about similar triangles. Very important topic. What you need to do this, of course, is your understanding of proportions, ratios and proportions. All you do is you plug in the number, like whatever A is, over D, and let's say you don't know what B is, right? So B might be the unknown over E, which you might know, and you just solve for the unknown, right? So maybe you have a situation. I'm just making this problem up on the go. 4 over 8 is equal to x over 12, for example, from two shapes. So you could just solve for x, right? You cross multiply and you divide by what, divide. So you have 8x is equal to 48, for example, and you divide both sides by 8. So solving equations is very important, and that's where we spent some time on that earlier on. And you use that knowledge to do similar triangles, right? So please let me know if you need more practice with similar triangles. But the focus here is not just on similar triangles, right? We've talked about how we can classify triangles based on sides, but based on their angles, right? There's these sort of angles. We call them acute angles, obtuse angles, right angle, right? You might be familiar with your angle 90 degrees, right? That is your right triangle right there. An obtuse angle is greater than 90, but less than 180. And your acute angle is less than 90. And so we have triangles and we have different sort of names for the angles involved. We can classify by sides, and we should be aware of the different angle configurations that can happen. Moving on to another part of discussing angles. Let's talk about the triangle sum theorem, or the idea of the sum, right? The sum of angles. Triangle sum of angles. The sum of angles of a triangle will equal 180, right? You add up all those angles and you get 180. There is a relationship between the side length and the angle, right? So imagine you have an angle like a triangle like this, and you have A, B, C. There's a relationship between this angle here and this length over here. You see, the longer this is, the bigger this angle would be. This over here that is short, as you can see, this will be the smallest angle. And then this one, of course, we don't, this is not drawn to scale. So this length and this length would be longer, and these sides would be, this angle and this angle would be bigger than that angle for sure, because of the side length opposite them. So there's a relationship between the angle and the side length. Keep that in mind. Now, all the angles will add up to 180, and that's important because if we only give you two angles and we don't give you the third one, you can find the third one. One of the theorems to keep in mind is called the triangle inequality theorem, and the idea of the triangle inequality theorem is basically, if you have a triangle, one side of that triangle, right? So the two shorter sides of a triangle must add up to more than the longest side. So if you have a triangle, the two shorter sides of that triangle, right? If A and B are the two shorter sides, they will add up to more than the longer side. So the two shorter sides of a triangle must add up to more than the longest side. For example, in this case, as I said, A plus B will be greater than C if these are the shorter sides and this is the longest side, right? It's just something to keep in mind with triangles. If you add up the sides, if you had like 5 plus 7 and it was greater than 8, then you know that such a triangle could, that such a situation might be a possibility, right? Again, this is not a right triangle here, of course. Right triangles have a certain set of numbers that that must fit the criteria. So when you have this situation, you can say that a triangle will not exist where you have a combined length of two sides being shorter than the longest side. That is our triangle inequality theorem. Another good tool to know is if you have a triangle like this, these two angles here, A plus B, will actually equal this angle over here. So let's call this D. So angle D will actually, so this angle over here will equal this angle plus that angle. That's just a quick trick for you to remember. But if you forget, you could always calculate it a different way. But just something to keep in mind that the measure of this external angle, that's an external angle from the triangle. The external angle is equal to this plus that. Now, how do we prove that? I know some people didn't like proof in geometry, but let me just mention this quickly. If we know that an angle at a straight line is 180 degrees, right? So let's call this A, let's call this B, and let's call that C. That means A plus B plus C was 180 to start with. And then we call this D. But we know that C plus D is also equal to 180. Do you see what happened there? So notice that D must equal A plus B in order for that to be true. So that's why one reason we know. So again, A plus B plus C is equal to 180. C plus D is equal to 180. Therefore, A plus B is equal to D in this case. Okay, just a short proof. We can go into more logical, formal proofs if you want in a different course. But this is just to remind you of the external angle relationship to the triangle. Now let's talk about right triangles specifically. Let's just mention the Pythagoras theorem. You might remember this, or the Pythagorean theorem. And basically what it says is that if you have A and you have B, and this is C, then A squared plus B squared is equal to C squared, right? So again, classic example 3 and 4. So 3 squared plus 4 squared is equal to C squared. 9 plus 16 would be equal to C squared. Sorry if I've gone a little faster here, because I'm assuming that you've probably used the Pythagoras theorem. But if you haven't, feel free to pause and go back. So 9 plus 16 is 25, which is equal to C squared. C is equal to the square root of 25, and C is 5, right? So we use the Pythagoras theorem, whatever these values are, to find the missing side. So this is a right triangle, and we use the Pythagoras theorem or the Pythagorean theorem to find the missing side. We can dive into this further in a different video. The next part of what we want to look at with this is special triangles. Let's talk about special triangles. Special triangles are one of my favorite topics in all of mathematics. And the reason why is because of just how nicely we can derive them and then how we can use them in everyday math. So imagine you have a square, right? You have a square, and all the dimensions of this square are 1, 1, 1, and 1, right? 1 and 1. And imagine if these are all angled 90 degrees, right? So you have a square, all the sides are 1, and you split it, you bisect those angles there, right? Now I'm going to bring out this shape over here. Okay, it's going to be like this, and we just bisected it. So we have 1, this is now 45, this is also 45, and this is 1, right? Because we bisected these angles. Now this is 1, this is 1. We can find this side using Pythagoras theorem, right? You have A, B, and C. So A squared plus B squared is equal to C squared. 1 squared plus 1 squared is equal to C squared. So 1 plus 1 is equal to C squared. C squared is equal to 2. And C is the square root of 2. So that's the square root of 2. Okay. So we have 1 square root of 2. So basically imagine, right, in an angle, this 45, 45, 90 triangle. Okay. So basically when we derived it, we got 1 square root of 2. And this was 45. And this was 45 as well. So the ratio is 1 is to 1 is to square root of 2. Now what's interesting is if I tell you here's a 45, 45, 90, or if you know this is a 45, 45, 90 triangle, and I tell you that this is 5, you should automatically know that this is also 5, because that's the relationship. And guess what? You already know what this is. This is 5 square root of 2. Because think of the 1 to square root of 2. Think of it as x to x to x squared of 2. So whatever x is, will be the same for another side. It's an isosceles, basically, triangle. And then the last one would just take what x is and put square root of 2 next to it. And that gives you the value. So very interesting. That's a 45, 45, 90 triangle. And there's another special triangle, okay? So let's look at this. Special triangle. 30, 60, 90. That's the other type. Imagine if you have an equilateral triangle with the side lengths of 2, 2, and 2. And imagine if the angles, well, the angles will have to then be 60, 60, and 60. But imagine if we bisect that angle up here. Well, what's going to happen? This will automatically become a 30. So 30 and a 30, right? And then this side here will be 1 and that side will be 1, right? This is still 60 and this is 90. So imagine if I extract this triangle, I will now have a 30, 60, and 90, right? And the side length here was 1 because we split it in half, and this side length was 2. This we don't know, but we can use Pythagoras theorem to find it. So imagine this is A, B, and C. So A squared plus B squared is equal to C squared. So we have A squared plus 1 squared is equal to 2 squared. A squared plus 1 is equal to 4. A squared is equal to 3. Then A is equal to square root of 3. So this is square root of 3. So with a 30, 60, 90 triangle, you have 1 is to square root of 3 is to 2. That's the ratio. So imagine if I give you a problem where I say, what is the value, right? If I give you a shape like this and I tell you that it's a 30, 60, 90, and I tell you that this length across from the 30, I tell you that that's 15, for example. Well, guess what? You actually know the other parts. If this is 15, this will be 15 square root of 3, and this will be 30, which is 15 times 2. See how neat these special triangles are? They make our math much easier to do, but I think they're just beautiful. Just the derivation is beautiful. And so please make sure, if you want to dive further into this topic, let me know. Otherwise, feel free to watch this video again if you want to see how this is done. But this is basically what you need. We've talked about triangles. We've talked about the area of a triangle before, which is half base times height. We've talked about the Pythagorean theorem. We've talked about special triangles. We've talked about triangle inequality theorem. And we talked about triangle, an external angle from a triangle, and the sum of angles of a triangle. So there's a lot to talk about here with triangles. I hope this was helpful. And let me know if you have any questions. Have a great day.